So 3D part 7 we have to do. So now we are going to do the equations of plane in different conditions. The equation of a plane in normal form. You see, in the normal form, the perpendicular distance from the origin is this. This is a plane. This is a plane which is, you can take this point A, B, and C. This is a plane. And ON, just imagine this is 3D diagram. ON is the perpendicular on the plane. Okay. From the plane it is coming out, and this is perpendicular distance from the origin. This is perpendicular distance from the origin, which is denoted by ON. And then we will take any point P on the plane X, Y, Z, whose vector equation, whose vector position vector is vector R. Okay. So OP, vector OP is, we have to find the equation of this plane in vector form and in Cartesian form. So OP is what? Vector R. ON is a distance D, but how will you make it a vector? So if you write ON vector will be equal to D into N cap. D into N cap unit vector. We will take unit vector in the direction of ON, perpendicular, in the direction of the perpendicular. So this will become a vector. When you will multiply with unit vector in this direction, so then ON will become a vector. So if you see in this diagram, so by triangular law of addition, OP vector plus vector PN, how we get the equation? Just see. Generally we are using triangle law and dot product. A dot B is equal to 0 if A and B are perpendicular. So OP plus PN is in the same direction, will be equal to ON. Okay. Now OP, what is OP? OP is vector R, and PN, we don't have PN, and ON is vector. Yes, Charik, 1 minute. I'll let you understand. DN. See, this is a plane. We can take this is a plane, any plane. This is a plane. Just you have to imagine 3D diagram. This is a plane. Here you have x-axis, y-axis, z-axis, x-axis, y-axis, z-axis, and you have given what? Origin, distance from origin. This distance perpendicular from the origin. This is perpendicular from the origin. This distance is given. That's it only. We have to find the equation of the plane. So in order to find the equation of a plane, we always take a point P whose coordinates are x, y, z. Any point x, y, z we should take on the plane to make its equation. And then OP is a general vector. Okay, Sharik? Understood? Okay, so very good. So this is the perpendicular from O to N. This is perpendicular from O to N, passing from the plane. It will go out like this. Okay, this is perpendicular. See that this origin, this is the distance from origin to perpendicular. It will not be same in other type of plane. D is not always the distance from the perpendicular distance from the origin. It can be any other distance, but here when it is given, it is perpendicular distance, you will take perpendicular distance. हमेशा D वो नहीं होगा, आगे आएगा, इसलिए मैंने बोला. तो PN is a vector whose value we are getting DN cap minus R. We are finding the equation of this plane. Okay, got it? Now this we got PN. If you will see that from N, this N is the perpendicular. ON is perpendicular or not? You can say that ON is perpendicular to PN. Why PN? P and N, just see that P and N are the points lying on the plane. These 2 points are on the plane. So this will be perpendicular. Just imagine 3D diagram. this is perpendicular to the plane. So any line which is joining to this line, whether here, whether anywhere on the plane, will be perpendicular to ON. So therefore, ON is perpendicular to PN. And what is the vector ON? Vector ON is this. When they are perpendicular, so we can say that dot product of the vectors Pn dot On when they are perpendicular, A dot B is equal to 0. Got it? Because they are perpendicular. When they are perpendicular, their product will be 0. A dot B is equal to 0 when two vectors are perpendicular, and this On is a vector, Pn is a vector, Pn is a vector, On is a vector, they are perpendicular to each other. So that's why their dot product will be equal to 0. And Pn, this is equation number 1, Pn, equation number 2, On, just put here, the value of Pn is d n cap minus vector r dot product with On is d n vector is equal to 0. Right hand side is 0, dot product is a scalar product, so scalar 0. Now multiply this dn inside, so dn dot dn dot dn cap minus r dot dn cap is equal to 0. Okay. Now d into d is d square, and n dot n cap dot n cap, what will be the value n dot n? N dot n is 1. A dot b, a both are 1 1, so their product will be 1 only. So we get r dot dn unit vector n, and this d is a scalar quantity, so d we can take out common, so we get d minus r dot dn is equal to 0. So this will become 0. We get this equation that is equal to r dot, not d, d will not come here, r dot n is equal to d. R dot n is equal to d. So this is the equation of a plane in the normal form. It is called normal form because we have given ON is a normal perpendicular distance. ON is a perpendicular distance. Okay. So that means we got this equation. This is the equation in the vector form. Here now we will convert this equation into the Cartesian form. This is what vector form we got in the vector form. So vector form, if you want to write the equation in vector form, we should know the d distance we can put here, and n cap unit vector we can substitute and get the value, get the equation of the plane in vector form. Now this equation we will convert into the, we will convert the same equation into Cartesian form. So in Cartesian form, I will convert directly this equation into Cartesian form. So this is the equation in vector form, r dot n is equal to d. R is a vector of a particular direction and n cap is always perpendicular. Then what is the direction of r dot n cap? R dot n cap, very good question. You have to be very careful about dot product. Okay. R dot n is not a vector. When you will find the, you ask that R is a vector in any direction, n is a vector N cap is a unit vector, and then what will be the direction? My dear, r dot n is a scalar quantity. It is a scalar quantity. How can you say that what will be the direction of a scalar quantity? It has no direction. Okay, your question is wrong. R dot n, that's why right hand side you are getting d. D is a distance. The dot product is always equal to scalar quantity. That's why. Okay. So now we will convert it into, okay, we will convert into Cartesian form. So R dot n is equal to d. This we have taken here. Okay. So now what is R, what is n, what is d? D is the distance from the origin to the plane, as you know. And n cap, what is n cap? N cap, I told you, n cap will have the direction cosines. If you are writing Li plus n will be mj plus nk vector. N cap will be this one. The element will be the direction cosines. Then it will be n cap dc. Because I told you what is n unit vector, n is equal to the vector divided by its magnitude. When you will divide it by its magnitude, these coefficients will become the direction cosines. Otherwise, they are direction ratios. So n cap will be the direction cosine. Okay, and d is a scalar quantity, nothing to do with d. D is a distance. Just you can put in the equation and you can get in the Cartesian form. So in Cartesian form, the same equation of a plane will become r. What is r? You know that r is equal to, is a vector in any direction xi plus yj plus zk plus zk. So this we put in the above equation, we get xi plus yj plus zk dot product of lx. Again, I am telling you, this is the equation where the direction cosines are given. Means this is n cap, unit vector. If vector n is given, we have to convert into the unit vector. Okay. So in the next part, we will see that one. So lx plus li plus mj plus nk is equal to d. So dot product, so it will become lx plus my plus nz is equal to d is the equation of a plane, normal form in Cartesian coordinates, in Cartesian form. Okay. Question, if you want, we can do the questions also, then we can go to the next part, or we can complete first all formulas and then we can start the questions. I think find the direction cosines, find the equation of the plane which is at a distance of, okay, I'll take one question. Okay. So now question is find the vector equation of the plane which is at a distance of this, and this is a normal vector, not the unit vector. So this is n. Okay. So before doing it, just see that what is given, normal vector. So n vector. So we have to convert into the unit vector. Okay. So normal vector is given. We have to convert into the unit vector. Unit vector is equal to vector. When any vector divided by its magnitude, it becomes a unit vector. So 2 square plus 3 square plus 4 square. So under the root 29. Here it is under root 29. 2i minus 3j plus 4k. Okay. Therefore, the required equation of plane is r dot, because we are writing in vector form, find the equation of the plane, find vector equation. It is ours in vector form, so we will write in vector form. R dot, we can write by splitting into their TCs. 2 by 29 root minus 3 by root 29 j plus 4 by root 29 k is equal to d. D is what? Distance given 6 by under the root 29. That's it. This is your equation. Okay. So like this we can do. This is the normal form. Now we are going to do the equation of a plane perpendicular to a given vector and passing through a given point. Yes, the second condition. Yes. Now we have to find, just try to understand the difference. Good question. You have to understand the difference. Equation of a plane perpendicular to a given vector. Equation of a plane. This is a plane perpendicular to a given. This is a vector. This vector n is a perpendicular vector to a plane. Any vector n, this is not the unit vector or the perpendicular from origin. In the previous question, n was O to n. There was a perpendicular from origin to the, see, this is in the previous one. What was n? Suppose this is a plane, huh? And from origin, when you drop a perpendicular distance, this is perpendicular, suppose n. So this was d. This was d in the previous one. Here n is a vector which is perpendicular to a plane. Equation of a plane perpendicular to a given vector means the vector is perpendicular to the plane, or plane is perpendicular to the vector. Same thing. So this vector n is given. Just see, this is vector n. This is vector n which is perpendicular to the plane. Got it? I think understood. This n is different from the previous n and passing through a given point. Okay. So there is a point from which this plane is passing. This is like a point. A point passing through a point whose coordinates are x1, y1 and z1. Okay, understood? If not, I will explain it if you. So a and p, just you can see p, we have to take anyway p point on the plane. So we are taking always p point. It is any point on the plane whose position vector is r always. But this is a point from which the plane is passing. We have the two conditions that the plane is perpendicular to a vector, and the second one, the plane is passing through a given point A. So what is the position vector of A? A is small a. So we have seen that OA. Now you can see vector OA is vector A. And vector OP, you know that vector OP is vector R. Okay. Vector AP, we don't know. Now again, we can do it in this triangle. We can use the triangle of vector addition. So OA, vector OA plus AP, vector AP will be equal to OP. And what is AP? AP is the vector, position vector of P minus position vector of A. You know that. What is AP? AP is equal to position vector of P. That means you can say OP minus OA. I told you before also. Position vector of P. What is the position vector of P? Is R. Position vector of A, R minus A. R minus AP is R minus A. Okay. So no need of this triangle law. We will go by dot product only. So now if you see that what is the relation between AP and vector n. Vector n is perpendicular on the plane. So any vector on the plane will be perpendicular to this vector. Correct? This is vector n. This is vector n which is perpendicular to AP. Correct or not? You are understanding? Vector AP is perpendicular to vector n. Therefore, their product will be equal to 0. So AP dot vector n will be equal to 0 and AP is equal to R minus A. R minus A dot n. N is any vector which is perpendicular to the plane. Okay. So this is the vector form. This is your vector form. Now it's Cartesian form. We will convert into Cartesian form. In Cartesian form, simply we have the A is passing through x1, y1, z1. So obviously the components will be x1i plus y1j plus z1k. And R, everyone knows vector R is a general vector whose value is always xi plus yj plus zk. N is any vector. N is any vector, but it is perpendicular to the plane. So n will be given any vector. So we can take here in a way to have A, B, small, capital. So we are taking capital AI plus BJ plus CK. This is the vector which is perpendicular to the plane. Substitute here. If you will put, I can do it directly, or if you want, I can put it here. So xi plus yj plus zk. Actually, you have to remember both the equations, because in doing the questions, you can use directly the Cartesian form and then put the values x1, y1, z1, and vector form you can put the values. So what is the value of this is what R minus A. R minus A. A is what x1i minus y1 j minus z1 k dot product with AI plus BJ n cap plus C k cap is equal to 0. Okay. Dot product. Before that, you can collect this x minus x1, x minus x1. This will become x minus x1 I plus y minus y1 j plus z minus z1 k. This is having dot product with AI plus BJ plus CK is equal to 0. Dot product, you know that how to do the dot product. I will cancel, corresponding elements will be multiplied. So A into x minus x1 plus B into y minus y1 plus C into z minus z1 is equal to 0. So my question is to Ayush. You can unmute yourself. tell me this vector n, what ABC are the, what do you call ABC are the what of vector n? ABC will be dash of vector n. Ayush, you can unmute yourself. I said and tell me.